Okay, so welcome to part 2 of Algebra, and in this session I'm going to cover linear equations and how to solve them. Welcome back also to the shambolically presented but hopefully informative style. So, linear equations. You remember from the first algebra session that we were talking about using letters so that they can represent any number, and therefore we can come up with generic rules. In this session, we're going to be talking about the letter representing a number, but it's going to be a specific number. It's a specific number, but we don't know what it is. And then later on, I'm going to start talking about formulae as well. And in that case, let's get on to that in a bit. Okie dokie. So linear equations. What's an equation? And I'm going to start off with a rather unconventional definition of an equation. Okay, an equation is two sets of things which are equal to each other, and I've deliberately drawn some kind of really poor old-fashioned scale there. So we all know that on one of these old-fashioned scales, the way it used to work is you used to pile this with flour or whatever it may be on here you put various different known weights, and in those old days there'd have been pounds and ounces and things instead. And the point at which you know that they're the same is when they're balanced. Now, when I write an equation, I'll start with a nice simple one. That's what this equals means. It means that these are balanced. Okay? X plus 3 is the same as 5. What's X? Well, we all know, probably, that X in that case is 2. And that was a very simple linear equation. And I've just realised I didn't explain what linear means either, and I'm not going to in this session. We'll come on to that when I talk about quadratic and other polynomials, and then you'll understand what linear means. Okay, but I'm going to ignore the fact that we all know that that's X plus 2, because I want to show you a technique. The reason I'm showing you the technique is because you can use that technique to solve all linear equations when it may not be quite so obvious what the answer is. Okay, I want you to imagine, coming back to here again now, that these are both 1 kilogram. Okay, now if they're balancing and I've got a kilogram of flour here, if I was to take exactly half of this flour out of this here, it wouldn't balance anymore unless I took exactly the same off here. Okay? Now this kind of leads us into two rules actually. The first rule is that I can subtract the same thing from both sides. And the second rule is that I can divide. And well, let's finish this first. You can divide the same by the same number. Oh, beautiful. I love it. This is so shambolic. Divide by the same number on both sides. Okay? And a little bit of a white lie here, but we won't worry about that. We'll talk about exceptions to this in later tutorials. And it's not a great leap of faith, is it, to realise that if you can subtract the same from both sides, I could add the same to both sides, okay, or add. In this case, if I'd added the same amount of flour again instead of halving it and put 2 more kilogram blocks on, they'd have still balanced, wouldn't they? And similarly here, I could have multiplied the amount of flour by 2, multiplied the number of weights by 2, so all multiply. So, in a rather laborious and boring way, I guess, I'm going to solve this equation by saying, look, what is my objective here? My objective is to get X equals something. Okay? And if I look at that left-hand side there, if I want X on its own, the party pooper really is this 3. This plus 3. So what I'm going to do, instead of just saying the answer is obviously 2, is to say let's subtract 3 from both sides, and it will still balance. That equals sign is the pivot in the balance. Okay, if I subtract 3 from here, I just get the 3. If I subtract 3 from here, I'll get 5 minus 3, which is 2. So it still works, and it may sound a bit boring, but it's a good technique, and you'll use it for harder ones, as I said. And similarly, if you've got 3x equals 9, I could divide both sides by 3, rather than just saying, oh, the answer is obviously 3. And if I divide both sides by 3, I get x equals 9 divided by 3, which is 3. Okay, so those are the basics in linear equations. What I'm going to do now is make an equation that may not be quite so blooming obvious to solve, in which we can use these rules. Okay, so here we go. 3x plus 7 equals 4 minus x. Okay, now you probably could, if you spent a little while thinking about it, solve this equation as well in your head, but my technique is starting to get a little bit faster than thinking it up in your head, and equations can get an awful lot more difficult than this. So what are we going to do? Well, remember my objective again is to get x equals. Okay, so what we need to do is just follow these two rules, 1 and 2, one after the other, to collect things so I'm down to something that might look like x equals at the end. And what I tend to do is focus first of all on the variable, on the x. I've got 3x here and a minus x here, and I don't want x's on both sides in my answer. I want x on its own. So what I'm going to do is take this minus x here and say I'm going to add x to both sides so that this disappears. If I've got minus x plus x, that's going to make 0. Okay, and I'm going to rub that out because I'm possibly getting better at my shambolic presentation skills. Okay, so I'm going to add x to this side. Remember, because it's a balance, I've got to add x to this side as well. So I haven't got 3x anymore, I've got 4x. I've still got the 7, but now that minus x is gone. Okay, and now I've got a bit closer. It's a little bit easier, but the problem now is this plus 7. I don't want a plus 7, I only want x's on this side. So to get rid of this, I'm going to subtract 7. So I'm going to get 4x equals 4 minus 7. Subtract it from both sides, so it still balances. And that is minus 3. Okay, so what have I got now? I'm just going to write that out again. 4x equals minus 3. So far I've used this rule twice. Once with the minus x, once with the plus 7. Now I'm going to use this rule. I've got 4 times x. I don't want 4 times x, I want 1 times x. I want to know what x is, not what 4x is. So to get rid of that 4, I'm going to divide both sides by 4. 4x, 4 lots of x, divided by 4 is 1 lot of x. So if I divide that side by 4, I've got to divide that side by 4 as well. So I'm going to get minus 3/4, which you could write as minus 0.75. So that is the next level of difficulty on linear equations, and I'm now going to, I'll see if I can, Kate's been teaching me how to do this. I'm going to try and add a new layer so I can just kind of lose that when I can find the blooming button. I'm not sure how to do it. Where is it? Eraser. By eraser.
No, left.
Left? Pencil texture, left?
Up.
Up there? Up. Oh, there, yeah. Okay. We might keep that in. Okay, here's the next level of linear equation. Makes it a little bit harder still. Okay, so what am I going to do here? Oh, crikey. I'm going to have 3x plus 4 on 7 equals minus 3. I'm just making this up at random, so we're going to get crazy results. Okay, so if you remember our two rules, you can add, subtract, or you can multiply, divide. You might see, and let's write our objective here again. Our objective is to get x equals. You might look at that plus 4 and say, I'm going to take 4 away from both sides. And And you might say, okay, that's 3x over 7 equals minus 7. You might do, but you'd be wrong. And the reason is because of BODMAS. And I haven't done a tutorial on that either yet. But this isn't telling us. What this is telling us is it's 3x and 4 are both divided by 7 because the division is more important. So I can't just subtract 4 from both sides of the equation. I could subtract 4/7, but it's actually easier to do the multiplying bit first. Okay, so what I'm going to do is multiply both sides by 7 first. That's going to give me 3x plus 4. I've deliberately multiplied by 7, remember, because I've got divided by 7. If I multiply by 7, they're going to cancel. And I'm going to multiply this side by 7 to get minus 21. And now it's looking a bit easier. Now we can subtract that 4. Okay? To get rid of that, I'm going to get minus 24. I've actually got a reasonable answer. Because 24 is exactly divisible by 3 for this. And now I'm going to divide both sides by 3. So x equals minus 8. Okay? I'm going to set some homework. And can I remember where this blooming thing is? I can. Okay, I'm going to set some homework in this one. Have a go at some of these and practice this. Don't just guess the numbers. Really try and use these rules. Try and remember about the order in which you do them. Because if you can master this, everything else is going to be a lot easier, I promise you. Without mastering this, maths is going to be hard. Okay, so let's start off. I'm going to use y instead for your homework. Okay, so y plus 3 equals 7. There's number 1. Okay, I'm going to have 3y plus 4 equals y plus 1. I'm going to have 6 minus y equals minus 2y. That's a little bit trickier. And I'm going to have 4 minus x over x equals 16. Have a go at those ones. See how you get on. If you get stuck, post some comments and I'll see if I can help. Okay, so that's it for basic linear equations. What I'm going to do next is move on to manipulating formulae, and we're starting to get a little bit harder. Okay, cheers, bye. If you enjoyed this tutorial, don't forget to like, comment, subscribe. If you put your questions below, I'll do my best to get back to you as soon as possible.